So now I'm going to talk about life. First, life on Earth, and then the potential of life elsewhere in the solar system. So as we all know, there's life on Earth. It's been around for a while. And life on Earth has had some pretty major impacts on Earth on a planet-wide scale. The biggest one of which is that Earth's atmosphere has like 22, I believe, percent oxygen, which is huge. No other planet even comes close to having that much oxygen. It's kind of wild. So, why is that? Well, it's because of life. So early on, Earth had a more normal atmosphere with very little oxygen in it. And the earliest life on Earth, this was, like bacteria and stuff. Very, very simple life. Was just kind of hanging out, doing their thing, you know. Not a whole lot going on with them, but at one point, one group of that very simple life, the blue-green algae, evolved a new method, a new technique, by which they could take energy from sunlight and use it in a chemical reaction to make sugar. This is what we now know as photosynthesis. And the ability to get food for basically doing nothing was at this time such a powerful and dominant skill that it gave them, the blue-green algae, a big advantage over lots of other life, and they spread very quickly and reproduced very quickly. Now, the thing about photosynthesis is that the chemical reactions involved create oxygen, O2, oxygen gas, as a byproduct. And the blue-green algae had to get that oxygen out of their system to keep it from sort of gumming up the works and screwing with their other chemical reactions. And so they respired, they exhaled that oxygen, and started over time producing a bunch of oxygen that then went into the atmosphere. And so that's why Earth has so much oxygen even today, from all the photosynthesizing life forms, like plants and stuff. Blue-green algae still exists, that are making oxygen all the time. So that's one of the big ways that life has influenced Earth. Now, let's talk about the possibility of life elsewhere in the solar system. Where might it be? What might it look like? So, I'll start this off by saying that whenever we're thinking about finding life somewhere else in the solar system, if we do find it, probably it's going to be like bacteria. It's going to be something very simple. If you look at the history of life on Earth, like substantially more than half of that time was all bacteria, right? So it seems like the jump to more complex life than something on the level of like bacteria or algae is a big jump to make. And so it seems pretty likely that if we found life somewhere else, that life probably wouldn't have made that jump yet. So probably we're looking at very simple life, but anything, even very simple life, would be easily one of the most important, coolest discoveries in human history. So let's talk about some things. Mars. Seems really likely that Mars used to have life. I mean, it used to be a lot like Earth, and Earth has life, so, you know, kind of stands to reason, you know, why would Mars be different? Maybe it doesn't now, but maybe it does. Like I said earlier, it has those aquifers, probably. Maybe there's some life still hanging out in there. It's possible. We don't know. Venus is a place I would have not thought was a good spot for life, and yet, recently in the news, a key biosignature, that is a molecule that we think is a pretty good indicator, a pretty good hint at possibly life existing on a planet, called phosphine, was discovered on Venus. Radio astronomers looked at absorption spectra from last week's lecture of Venus's atmosphere and saw clear signs, unexpectedly, of a molecule called phosphine, which is thought to be a very compelling biosignature. On Earth, phosphine is only made by certain life forms and in industrial contexts. We don't really know of any good ways to make phosphine without life, but Venus has a bunch of phosphine. And they went through all the ways they could think of that Venus might get phosphine without life, and they found that the amount of phosphine Venus had was like thousands of times higher than any of the processes they could think of could account for. So, we're kind of left with two possibilities. One, there's a way of making phosphine that we've never seen before and have never heard of or even guessed at before without life, and that's what's happening on Venus. Or there's life on Venus, like right now. That would be pretty cool. Now you might be thinking, but Venus is so hostile, it's so hot and has so much acid, how could there be life there? Good question. See, the surface of Venus is extremely hot and extremely hostile, but these signatures came from portions of Venus's upper atmosphere, and there are parts of Venus's upper atmosphere that's of a much nicer, more Earth-like temperature. Those places are still really, really acidic, but, you know, there's life on Earth that can deal with extremely acidic environments. So it stands to reason that life on Venus could, find a way too. And, of course, would be shaped by its environment, so probably would have some pretty interesting ways of dealing with all that acid. Talked about Mars. Okay, I'm going to get to Europa. First I'm going to talk about Titan. So Titan is so Earth-like, with its rivers and lakes and oceans and rain, that it's like we kind of have to think about life on Titan. But the thing about Titan is there's no liquid water on Titan. It's so cold. And liquid water is absolutely critical for life on Earth. It facilitates all kinds of important chemical reactions. So if there is life on Titan, it would have to be life that has a very different fundamental chemistry than we do. It would have to use a fundamentally very different set of chemical reactions as the basis for its life than life on Earth does. And so I think Titan is a really good example of how we might find life that really doesn't look very much like life on Earth at all, in maybe unexpected places. Now let's talk about Europa. Europa is my favorite spot for life in the solar system. I really think, honestly, that if we could get to Europa, and if we could, build a drill that could get through Europa's outer ice surface and into its massive subsurface ocean, an ocean that goes all around the moon, liquid water all throughout, I think we would find life. I really do. I think it's there right now. And I'll explain why. So, there was a period during the early solar system, I mentioned this earlier, about a really chaotic period where stuff was crashing into each other all the time. This was called the Great Bombardment. As a period in Earth's history, was called the Great Bombardment. And we have evidence that life on Earth was not just existent, but widespread, only 500 million years after the Great Bombardment ended. Life couldn't really exist during the Great Bombardment, but only 500 million years after it became possible for life to exist, it was already widespread. Now, 500 million years, that sounds like a long time. And it is. But the universe is about 13.9 billion years old. So 500 million years is about a 28th the amount of time the universe has existed. So, like, that's definitely a significant amount of time on, like, a cosmic scale in the grand scheme of things. It's significant, but it's small. It's a small, significant amount of time. And so, if life really is some really unlikely thing, some insane chance event, then for it to happen almost immediately, as soon as it became possible on Earth, would be like 2 1-in-a-million things happening back to back. What are the odds? What are the odds? I don't think the odds add up there. I think what that says to me is that when the conditions for life exist, life isn't that unlikely. It's pretty much inevitable. It's not going to take that long for it to happen. And let me tell you, the conditions for life exist on Europa. Europa, like I said, has this big subsurface ocean. And we can see from its surface that it has a lot of organic compounds. Lots of stuff with carbon in them. Carbon is very important to our chemistry because it forms a lot of molecules very easily. And Europa, it's got those organics. It's got that carbon. We can see some of it in like these reddish stripes on its otherwise very white, icy surface. It's got them. Now, Europa also needs a source of energy. This is a little more of a problem. We have the sun, right? But Europa, the place where life would be in Europa is in the ocean, but no sunlight's getting there. The ice shell is too thick. But Europa has a different source of energy. Tidal energy. What's that? Well, like I talked about earlier, Europa has a very powerful tidal interaction with Jupiter. The way this works is, if you recall my Kepler-Newton content, gravity is proportional to the distance between two things. And when you have something as big as a moon, and you're thinking about its gravity with like a really big planet like Jupiter, the difference between the force of gravity on the side of Europa that's facing Jupiter and the side that's facing away is significant. It's like an appreciably stronger force on one side of Europa than the other. And this causes Europa to get stretched a little bit. But, on top of that, you may also recall when I talked about the orbital resonances between Europa and the other Galilean moons. When they get close to each other, the moons exert a tidal force on each other. And so when Europa gets in this kind of a situation, Europa goes from its normal level of stretch with Jupiter to getting even more stretched, and then getting back to its normal amount, and then getting even more stretched. It gets flexed like this. And this creates a tremendous amount of friction inside of Europa. It creates a great deal of geothermal energy. And this geothermal energy could be used as a basis for life in the same way that the sun is the basis for our life. And when I say that, I don't mean just could. We know it could, because it happens on Earth too. In certain parts of the very deep ocean where no sunlight can penetrate, there are thriving ecosystems around things called hydrothermal vents that shoot really hot chemicals in water into the surrounding water. And there are bacteria that can take those chemicals and, in a process somewhat similar to photosynthesis called chemosynthesis, get energy out of them. And so these bacteria, which form huge mats on the floor around these vents, become like the plants of the ecosystem. You could have the same kind of a situation on Europa, 100%. So yeah, Europa has my vote as most likely place to find life like ours in the solar system. Enceladus, also, basically everything I just said about Europa applies to Enceladus too. Enceladus doesn't get as much tidal energy as Europa does, but Enceladus is also much smaller, so it doesn't need as much to accomplish the same thing. So yeah, those are kind of the potentials for life in the solar system, I think. I think that about does it for the solar system. Thanks for watching.